All right, so let's, the first thing to do is to figure out where all these forces are acting on the beam. I'm going to figure out the distances from the left side because that's where our F1 is being exerted, right? So F1 is going to be 0 meters from the left side, right? Then we've got a person, the weight of which 45 times 9.8. So that 45G, that G is 9.81. Okay, and this is the person is 3 meters from the left side. Okay, so they are at 3 meters. Okay, then there's the beam itself, which is 15G. And then that is, we're going to assume that the gravity of the beam acts at the center of the beam. So we're going to say at 4.5 meters, right? And these G's are all 9.81s. I'm just not putting them in because it makes it look nicer without them. All right, and then we've got F2, which is acting here. And F2, notice that F2 is 3 meters from the right side. Well, if the beam is 9 meters long and we're 3 meters in, this is at 6 meters. So F2 is at 6 meters from the left side. Okay, do we all understand this? So 3 meters from the right side, if this is 3 meters, and this is 9 meters all the way over here, then that's 6 meters there, right? Okay, so now if we look at the y direction, we're gonna have two equations, one for the y direction, right? The y direction is F1 up, right, plus negative 45 times 9.8, 1, minus 15 times 9.81, right, plus F2 is 0. Now remember, this is just up and down. We don't need to multiply by a distance. It's just either is it up or is it down. Positive is up, so this is up, right? This guy is down. This guy is down, so the forces of gravity are down. These G's are 9.81s. Okay, and then we've got 0. So now we have two unknowns. We can't solve that. So now we have to set up our torque, right? So let's set up the torque about the left side. About the light side. All right, so our torque about the left side is 0 times F1. So the F1 has no torque because it's acting on the hinge, right? And then this is going to be a clockwise torque. The weight of this person, the weight of the beam will be clockwise. So we go plus 3 times 45G plus, and then we'll go 4.5 times 15G. Right? These G's are 9.81s, right? Okay, so let's see. And then we have an anti-clockwise torque, right? So we have minus 6 times F2. And then that's going to equal 0. So that's clockwise. That's clockwise, right? Because these are going to tend to spin it this way. This will spin it this way. This will tend to spin it that way, anti-clockwise, right? So for torque, the positive and negative is clockwise and anti-clockwise. For the y expression, is it up? These are up. These things are up. These things are down, down, right? All right. So now we can solve this. Let's solve this thing for F2. Okay, so I'm going to go 3 times 45 plus 4.5 times 15, get the answer, times 9.81. And I get 1986.525, and then I'm just going to divide by 6. Let's see. 331.0. Yay! Okay. So my F2 is 331.0875 newtons. And the fact that it comes out positive means that it's up. Okay, so F2 is 331 newtons up. Okay, so now I want to plug that in here. So now I'm going to go F1 minus 45 times 9.8 minus 15 times 9.8 plus F2, and F2 is 331.0875. That has to equal 0. So you plug that in to You plug that in and you get the expression like this. Now I have only one unknown to solve for. So let's solve for this guy. All right, so let's see. I guess what I'm going to do is I'm going to throw this on the other side. So I'm going to go the opposite of the thing I just got, plus 45 times 9.81 plus 15. And I get that F1 is positive 257.5125 newtons. So I have to say that F1 is 258 newtons up. All right, I think we got the right answer. I think maybe I even explained it in a coherent way. I just don't know.